Okay, here we're looking at a pilot light, that's the flame here, heating a thermocouple. This is a thermocouple here. So what is a thermocouple? What does it do? Okay, it is a hot and cold junction. Now that makes a lot of sense. They're hot junction and cold junction. If there are two dissimilar metals placed together, they will produce power out of the two wires that are hooked to those two dissimilar metals. So if I weld a couple of metals together that are dissimilar metals, they will actually produce a small direct current when heated. Now the type of thermocouple we're looking at here is what we use in furnaces and water heaters and things like that. These are a safety device. So what's actually inside? Okay, the jacket of this thing here is made out of stainless steel. That's one of the dissimilar metals. The reason it's made out of stainless steel is I can put a flame on it and it won't deteriorate. Some other metals, if I put a flame on them, they'll eventually oxidize. This stainless steel will not. So it is welded or brazed, whatever the heck, to a very small little piece of wire inside there that is called copper. It's a mixture of copper and nickel. Okay, so this is the hot junction here. These welded or brazed together will produce a voltage across the wires that are hooked to them. The cold junction is actually down here. This is a lot colder than it is up there. So as long as there's a temperature difference there, it will produce power. For most of the gas applications we use these for, they're just safety devices. They're supposed to shut down if there is no flame. If this flame goes out, the power drops off of there and it lets go of a magnet that it's been holding in. So it doesn't really produce any great amount of power. I mean, there's a million kinds of thermocouples out there. There's everything. A lot of them used for sensing temperature and everything like that. But that's not what we're concerned with. We're concerned with this safety device. Okay, that's a thermocouple. It has one junction. Okay, here we have a thermal pile. Now, it's no different than a thermocouple. And you can see it's a lot bigger, but it's got a whole bunch of thermocouples placed in series. So when we heat this with a pilot light, it actually produces about a half a volt. And we can actually operate some gas valves and the like. So it's a power source here. Here again, we're not talking about any great amount of power. It's pretty hard to get a lot of power out of a thermocouple or even a thermal pile like this. They can be used for small loads that can be energized and de-energized of a thermal pile, or even some cases where a thermocouple can be used as a power source. But it's a very, very tiny bit of power. I'm going to show you the inside of what a thermocouple looks like when you cut it away. Okay, here's the thermocouple kind of taken apart. Here's the stainless steel portion, the outer portion, and this is the copper portion. See, this actually fits inside like that and actually sits there kind of like that. And there, you can't see it very well, but there's a very thin insulating layer in there so that farther down they don't short out together. But that inside's a copper, the outside's a stainless steel. They are bonded together. It's brazed, welded, something at the very top, and that's the hot junction. Okay, that is the two metals that make up a thermocouple. And a thermal pile is just a whole bunch of them put in series. Okay, and here's a diagram of
what it looks like. You can see that inner piece, the copel part and the stainless steel outer piece, and there's supposed to be 400 degrees difference between the two. And then there's a wire that goes down to the contact button and so on. So that's the way those things are made and why they work.